hypothesis testing here. We're looking specifically at one proportion z-tests. So just to recap what we did in the last video, anytime you're doing a hypothesis test, you want to follow the following 6 steps. You always want to state your hypotheses, so the null and the alternative. You want to determine the probability that you need to calculate. You can check the 4 conditions required to use the normal approximation. Calculate your p-value, make sure you always draw a picture. Decide if you want to reject the null or fail to reject. Remember, you never want to accept the null. And then write a clear summary that includes the p-value and whether you rejected the null hypothesis or failed to reject it and why. So in the last video, we had a p-value of 0.34, and we said that we reject a null if the p-value is small, and then we don't reject if the p-value is not sufficiently small. So how do we know if it's a small p-value or not? The p-value needs to depend on the context of the situation, but what we use is what's called a significance level, and it's the Greek symbol alpha. It's the threshold for which we can reject a null hypothesis. The most common significance level is alpha equals 0.05, and that actually stems from confidence intervals that we talked about in chapter 18, which was, one of the most famous or most used confidence intervals is the 95% confidence interval, and 95 plus 5% equals your 100%. So this means we reject the null as long as the p-value is below 0.05. Now, if you're in the social sciences, you may see a larger significance level, such as alpha equals 0.10. In medicine, where the consequences of missing something can be dire, you'll see much larger significance levels, such as alpha equals 0.01. This means we wouldn't reject a null hypothesis unless the p-value is below 0.01. Same thing with engineering, like if you're looking at like the wings of an airplane, the alpha level you would want to be really small. A university has found over the years that out of all the students who are offered admission, the proportion who accept is 0.70. After a new director of admissions is hired, the university wants to check if the proportion of students accepting has changed significantly. Suppose they offer admission to 1,200 students and 888 accept. Is this evidence of a change from the status quo? Perform a one proportion z-test at a significance level of alpha equals 0.05. And we're going to show all the steps listed above. Okay, step number 1, we want to write our hypotheses. So my null hypotheses here would be the proportion of students who are offered admissions and accept is 0.70. But the alternative is we're looking to see if the proportion has changed significantly. That's not greater or less, that's just not equal to. So we're dealing with a two-tailed test here. Step 2, we're going to look at what probability we need to calculate. So we're going to find all of our things that we need, like our sample proportion, p hat. So we find that here, out of our sample of 1,200 students, 888 accepted. And 888 divided by 1,200 gives me 0.74. Next, I want to find the standard error of p hat. So I'm going to take the square root of p times 1 minus p divided by n. And here when we do all the dividing and square rooting, you get 0.0132. I want to find the z-score. So where is this 0.74 going to fall on the normal model? So I'm going to subtract the mean, I'm going to take my value, my p hat, minus my mean, divided by the standard error. And when you do that, you get 3.03. So I know the p hat is more than 3 standard deviations above and below the mean. And the way I know that is because it's two-tailed, it's not equal to. So when we draw our normal model, you're going to see we're going to have 2 flags on this. So here we're looking for the probability that z does not equal 3.03, which really, so if you think about the the model. Okay, let's draw that so you can kind of see what's going on here. Right now you have the proportion that accept, which is 0.70. And then, of course, you can go 3 standard deviations in either way. So we would add 0.7 or 0.0132 to this to get each of these. But I'm looking right here at 3.03. That's where my flag's going to go, about a little more than 3 standard deviations above the mean. Okay, but remember, it doesn't say greater or less. It just says not equal to. So that means it could be greater than it, or it could also be less than at z equals negative 3.03. So that's how it becomes two-tailed, because it could either be more than it or less than it. So what we do here is just pick one. Maybe z is greater than 3.03. And all I need to do, since the areas are the same, because I know one of the characteristics of the normal model is it's symmetric, I'm just going to multiply my answer by 2. So in other words, we're finding the area here, but then we're just going to double it, and it's going to give us the area for both, okay, or the p-value. So I just need to remember when I do normal CDF that I multiply by 2. So what I'm finding is 2 times the normal CDF. Okay, so here's really like step 4. And when I do that, I need to, since I picked z is greater than 3.03, I know that's my lower bound. My upper bound is 100, and of course my mean and standard deviation are 0 and 1 respectively. And when you do that, you get 0.0024. So now my last step is actually steps 5 and 6. I need to figure out if I'm going to reject or fail to reject, and then I need to interpret my answer. So again, this is your p-value, and what I'm going to do to decide if that's low enough is I'm going to compare it to my alpha level, my significance level, which is 0.05. And since my p-value is less than my alpha level, right? This is 0.24%, that's 5%, so it's less. We're going to reject the null. Because basically what we're saying is, if the null actually were true, if the proportion of students who accepted the admissions is 70%, the probability that I would see a sample size this low is 0.24%. So therefore, we're throwing out the null. We're like, okay, I don't think there's enough evidence to say that the null is true. So I'm going to reject the null. So anytime you reject the null, you would say there is strong evidence in favor of the alternative. Remember in the last problem we did in the last video, when we failed to reject the null, we said there was not strong evidence in favor of the alternative. So you always want to relate it back to the alternative. Okay, so here there is strong evidence to suggest what? Well, go back to your alternative. The alternative says the proportion is not 0.70. So here, you can also phrase it as there is a change in the status quo, right? So to suggest there is a change in the status quo. So the proportion of students accepting admission is either more than or less than 0.70. If we look at our p-hat, it's showing that it's slightly more. So change in the status quo or change in proportion of students accepting admission. Okay, what I would suggest is that you try the next two problems and try them on your own, and then you can come back to the next video if you would like to see how to work them out.